All right, day 50. Woo, 50 videos. Look at that. Find the k closest elements. This is a medium problem, and it uses the modified binary search pattern that we are currently evaluating over here. I believe that is the 9th pattern that we're evaluating. So it's a group of problems where the solution involves binary search in some sort of way. And yeah, k closest elements, medium. This is a problem statement. We have a sorted array of integers, nums, and two integers, target and k. We want to return k number of integers that are close to the target value. The integers should be in a sorted order. Okay. Then this is the criteria for what's close to what. However, this example can make things even clearer. So we have this array of integers sorted in ascending order. We have k of 4, we have target of 3. So we want the 4 closest numbers to 3 in this array, which will give you 1, 2, 3, and 4, which does make sense. So case 4, we need 4 integers that are close to the given target 3. And you want to prioritize lower numbers to higher numbers. That's why, for instance, it's 1, 2, 3, 4 instead of 2, 3, 4, 5, right? Even though 1 and 5 are equidistant from 3. Now we have a target of 6. It's not even in the array, but we want the top 3, so just get these last 3 numbers and booyah. That's it. Here k is 2, target is -1, so it's somewhere out here. Which top 2 things closest to that are these, and we return them. That's all there is to the explanation for this problem. On to the solution. So in the solution, we have this huge body of text as per usual, but the diagram tells all. So let's go straight to the diagram, shall we? So we have this example array. We have a target of 4 and a k of 4. So we want the 4 closest elements close to 4. And what does that look like? So we use binary search to find the first closest element to the target. And the first closest element to the target is 4. So we use binary search to zone in on that, zone in on that. So we find 4 with binary search, and we create, so our 4 is the single closest element, the first closest element, right? Because remember, we want top 4 closest elements, but we need to find the first one to get started. And then we have a sliding window, which is another pattern, one of the first 3 patterns that we've covered in this whole series. And we have a left and a right on that element, a sliding window, initialize the window left and window right pointer. So we do that. Again, it's like a recipe, like a cookbook. So I'm a chef trying to break down what these cooks from Educative have whipped up for us. So we do that. So we found the middle, and then we initialize the left and right pointer, one element to the left and right of that value. Now, both numbers have the same distance from the target, so we prioritize the smaller of the two. So we always prioritize the smaller element and move the window left towards the left, because we're looking for 4 elements, right? So we'll move left to the one step to the left. Now we have 2 elements in the window, but the element size is not up to k. We want 4 elements. We're at 2 right now. So we have to move right 1 step to the right. Now 3 elements, we're not done, but now they're equidistant from 4, so we're going to move the left 1 step to the left. And then we have 4 elements in the array. We have the 4 closest elements so far. Fairly straightforward. What does this look like with code? So we do some preliminary work. This is the function that does all our heavy lifting. We pass in a number array. The number of elements we want to be close to target over here. So if numbers.length is equal to k, if it's the same, if there are as many elements in the original array as we want to find that are close to that target, we just return the original array, which does make sense. If it's less than or equal to the first element, if target is less than or equal to the first element in numbers, return the first k elements from numbers, which does make sense. And that's what this slice operation does, from 0 to k. So if it's outside, for instance, in the -1 case that we showed earlier, just do this, right? If it's greater than or equal to the last element in nums, return the last k elements from nums. So if it's bigger Then the very last thing in the array, just return everything, the last k elements from num. And that's what this does. The slice operation does. It goes from this to the end of the array. Now, we've evaluated those cases, right? Those short circuit cases. Now we've come to a point where, okay, it's somewhere in the middle. And that's what we're going to do here. So we want to find the first closest element using binary search. And the first closest element is a binary search operation on numbers and target. We've covered that quite a few times, but this is what that algorithm looks like. So we have the array, we have the target, we initialize the left and the right, we find the midpoint. If it's equal to the target, return the index of the midpoint. If it's less than the target, we want to move the left. Reformatted the text a bit. So similar, simple binary search operation. You find a mid. If you found what you're looking for, return that index. Otherwise, if it's smaller than what's at mid, if what's at mid is smaller than what we're looking for, then shift the left to the right of mid. Otherwise, shift the right to the left of mid. And you keep doing that ad infinitum until you're done. So you find the first closest element. Now initialize the sliding window pointers. So the window left, first closest one on the left, and the one on the right. So in the code example, they get the first closest, then they set the window left to the thing to the left of it, while the window right they set to what's on window left plus one, which in this case would be first closest pretty much. So that's not, so in compared to the diagram, R is supposed to be at 4 if we're keeping it a buck. Yeah, that's pretty much it. But everything kind of still checks out. Until the size becomes equal to k, expand the sliding window until the size becomes equal to k. Aha. So now we just want to make sure this stops being less than k. So we keep doing some operations until window right minus window left minus 1 is no longer smaller than k. It's grown, because in this while loop we're going to grow the window, the distance between left and right, to the point where this breaks. Now, if the left pointer is going out of bounds, move the window rightward. Okay, so if the left pointer becomes like -1, just skip to the right, which is like an edge case that we handle over here. If its right pointer is going out of bounds, or if the element pointed to by Windows left pointer is closer to target than the elements pointed to by its right pointer, move the window leftward. Okay, so what's this saying? If window.right is equal to the end of the array, in hindsight, this problem is actually closer to hard than medium, because this is a bit hard to think about. So if the Windows right pointer is going out of bounds, or if the element pointed by the Windows left pointer is closer to the target, so if what's at the left is closer to the target than what's at the right, move the window to the left. So if what's at the left is closer than what's at the right, so if what's at the left, the distance from target is closer than what's at the right, expand what's at the left so that there's a balance between what's at the left and right. Otherwise, expand what's at the right. So, and that means if what is pointed to at the right is closer than what's pointed to at the left, move it rightward to balance what's on the left and right. Okay, I guess not too bad, but kind of hard to visualize, especially in light of this diagram. But this is what it looks like. This is what the solution looks like. And then when we're done doing with all this, it's definitely worth coming back to. This entire operation, we return a slice of the window left plus 1 and the window right. So the slice operation on the numbers array. So when we're done, window to the left plus 1, because it's inclusive. Slice is always inclusive of what's the first argument you pass, and window.right. That's all there is to this problem. So it's quite fancy, to be honest, but this works. And it's the type of thing where that is arrived at by a lot of trial and error. Like if you were gonna discover this solution, it would be a lot of trial and error and inspecting of elements and like before you would land at something like this. especially this if statement in here. It's like gobbledygook. So checking if it's equal to the end of the array. If you reach the end of the array on the right, only move left on the left, right? Because there's nowhere to go on the right, so this should never be called, otherwise you're gonna have nonsense. And then checking, oh, is the balance not right? Is what I have on the left side less than what I have on the right side, distance-wise? Then expand, let the left match the right, right, by becoming bigger, essentially. Otherwise, make the right bigger. It does make sense, I guess, but you have to think about it quite a few times. And that's all there is to this problem. Thank you for watching. See you around.